Hi, everybody. Good morning, good afternoon, good evening. Welcome to Power of Knowing Forum's LinkedIn Live episode 142. Today, we are discussing on a topic of blockchain demystified, how smart contracts are reshaping the global trade. To discuss on this topic, we have the honor of having Araf Karsh Hamid, an entrepreneur, author, speaker, and Magic founder and CTO. Without further ado, let's bring Araf onto the platform. Araf,
Yeah.
good evening. How are
Hi,
you, sir?
Prem. Yeah. Good evening. How are you?
Good, sir.
Okay.
Sir,
Yeah.
without further ado, how can you explain us in simple terms on what is smart contracts and how they work, why are they required, and why is that a game changer for us on the global trade?
Okay. So the basic idea. Let's take the basic idea of contract itself, right? So when you say a contract, right, it's always between two parties, right?
Yeah.
Because if there is only one party, right, there is no concept of a contract,
Hmm.
right? So contract is always between two parties. Okay.
Correct.
So if you look at any traditional applications, right, you take any enterprise application, right, applications are always for that enterprise.
Hmm.
Okay, so there's no concept of a contract coming into picture because the enterprise will have its own rules, right? Right, and the entire concept of having a contract with another party, right? That's outside those business logics are outside the typical enterprise application,
Mm-hmm.
and the results of the contract which is happening between two let's say there's a manufacturer and supplier, and they have a contract in terms of getting some goods, right, finished goods or raw goods or whatever it is, right? Then those contracts will be some legal documents, and then based on the contract, both the parties will have their own applications, and the results will be fed into the application with in a completely different set of users, right? Different their own each company will have their own database and everything.
Hmm.
Okay, so that means the contract is outside the application, right? And the after effect of the contracts, right, in the entire life cycle of that contract and the delivery of the materials and everything, that goes into the application, respective application for each company. Okay, now the reason why they call it smart contract, because now the contract is not outside the enterprise app,
Okay.
it's within the enterprise app.
Hmm.
The difference over here is, no, the enterprise app is not just for the one company. The same app is handled by different companies, right? Depends upon who all are involved in that particular business contract, right? And then what exactly the contract is all about, how many parties are involved, and then and based on some transaction need to be committed, and then the contract says that both the party need to agree or sign, then all those things will is part of the contract, and those contracts are digitally written, which is
Hmm.
basically a program is written for that. That's the reason
Okay.
why it's smart contract, because it's always between two parties.
Okay.
Okay.
Yeah. Got that. What are some misconceptions you came across regarding smart contracts, especially in the industry leaders are skeptical about?
Yeah. One of the key misconception is basically, let's say when you say a smart contract, right?
Hmm.
People say, okay, it's you can 100% trust it.
Yeah.
Okay, so now there's a misconception in that, because even though, I mean, blockchain is all about trust and everything, right? Whatever the software you're writing, right, it can be vulnerable. There can be
Hmm.
bugs in the software, right? That can potentially create a problem. Like for example, somewhere in 2016 or 2017, I don't remember exactly the date. There is a hack happened on Ethereum platform,
Hmm.
right? And then there is a lot of data loss, right, incurring millions of dollars, right? And that's because of issue with the smart contract, because the smart contract had a vulnerability,
Oh, okay.
right? So just because you're writing a smart contract, that doesn't mean that no, the contract will be 100%, because end of the day, no, everything is written and created by, right? So you need to ensure that, no, like for example, when you do a physical contract between two parties, right? Both the
Hmm.
lawyers will go line by line to ensure that, no, there's no loopholes, there's no issues in the contract, which can affect
Okay.
any of the party, right? So, like the way the experts or the legal experts check the contract, your physical contract, right? Line by line. Similarly, a smart contract also need to be checked and verified by both the parties, right? And architects and everything to ensure that there is no vulnerability in the code. And if there is
Hmm.
a vulnerability, like any security vulnerability, right, that can be exploited by a hacker, and then it can be there can be issue with that basically.
Yeah. Okay. So there was a gap, is what you found, and that's where the gap has created some kind of challenges. That's what you're saying, Ashraf.
That's right. That's right. So and that actually potentially there's a heavy loss in transactions, and then from a finance perspective basically. So that the
Okay.
company got into the platform. It was built on Ethereum platform. So the company
Mm-hmm.
built that entire thing, right? They got into a lot of issues because of that, right? And then
Mm-hmm.
the lot of things has to be done to recover from that point basically.
Okay. Now, looking at these contracts coming in place,
Hmm.
smart contracts they have been already been in the market for some time, right?
Hmm.
Raf, if you look at,
Yeah. Hmm.
and while we look at how is this going to shape the global shape or reshape the global trade landscape, is there anything that you can help us with in terms of an example or a use case where we can talk about how this was notably enhanced the way we did business and also brought trust between smart contracts? Any such use case that you can bring into play?
Yes, yeah. Like let's say the it's basically the distributed ledger technology, the blockchain technology.
Hmm.
It's used across governments, across countries. Right?
Okay.
Like as it's not a typical application the way and you are building an application for an enterprise, right? Because here, if you're going to build a smart contract only for
Hmm.
one company, that
Okay.
doesn't make any sense. Like I said, no, contract means it's a contract between two parties.
Right.
So there has to be always two companies coming into picture, right? So one
Hmm.
example for but there's a lot of momentum happening is like for example a Walmart, they
Hmm.
created a blockchain technology to ensure that all the materials, all the products what they're getting from a lot of different suppliers across, they can trace back, and that's one of the key benefits of blockchain technology. They can trace back the origin of that product which is coming from where exactly it started, when it
Hmm.
is shipped, if it is a perishable good, what exactly the health of that particular stuff, right? Is it safe, is it good, right? So they can literally track at every moment, and then combine that with the IoT devices, right?
Okay.
In a supply chain, in an entire supply chain pipeline, right? You
Hmm.
get proper information, verifiable, auditable information, right, across the chain. So supply chain, right? So the companies who are involved in a lot of supply chain activities. I mean, there'll be like if you look at Apple iPhone, right? Uh,
Hmm.
you'll buy an iPhone from an Apple, but there are
Right.
almost 1,500 different components are there in the iPhone,
Right.
manufactured by a lot of different companies across the world, right? It's not done by one person or
Yeah.
one
Yeah.
company or one entity base, right? So then there's a huge amount of logistics happening, right?
Hmm.
And then ensure that everything happening on time, right? Nothing is I mean, delayed, right? And then if something is going wrong, then that's been tracked, right? So that's the way the smart contract with the blockchain kind of a technology plays a big role, because it is much more efficient compared to the traditional way of you have silos of enterprise application, and then you spend a huge amount of time, right? Trying to figure out how exactly everything is happening, and verify everything. So supply chain is one big area where smart contracts plays a big role. Again, when you look at the supply chain network, right, it's across the world. It does
Yeah.
not depend upon one company or other company, right, or one country or another, right? It's across the world. So similarly, there's one more key area which is again amplified, especially after the Ukraine war, right,
Hmm.
where the US started. I mean, of course, US started using SWIFT as a weapon
Hmm.
right, to sanction and everything, right? So
Yeah.
the countries across the world, right, were not happy with that. Even though, I mean, the war on Ukraine was absolutely, I mean, what the Russia did is absolutely wrong, right?
Okay.
But then the thing is that sanctioning on SWIFT network, which is a financial network, right,
Hmm.
it's created a problem across the world. So
Hmm.
now there is a blockchain-based technology is coming up, right? Where 4 or 5 countries are partnering. China is promoting that heavily, and again, it's going to be part of the BRICS network, the big BRICS countries, right? Where
Hmm.
the cross-border financial transactions can be done using a blockchain technology.
Now, coming to that point where you said cross border, this one, I
Mhm,
want to understand specific challenges or complexities,
mhm,
okay, or the global trade.
mhm,
Example, like you spoke about cross border. I
mhm,
wanted to have it little more multi party agreement
mhm,
and cross border regulations when it comes to in
mhm,
picture.
mhm.
How does this smart contracts help in simplifying it?
Yeah, so if you look at the Mbridge, right, that's across 4 countries. I
Hmm.
think Saudi, I think it was China, Hong Kong, Thailand, UAE, right, and then the first set of transactions they did. It
Hmm.
has been the project was on for last 4 years. I think just to a few months back they reached the stage of minimum viable product. Now there
Okay.
are 25 banks, which includes HSBC, Bank of China, Citibank, right?
Hmm.
All the international banks are there, right? And so all these banks, right, all the enterprises who involved, they all have contracts, right, between each country, between, right, everything, right? So all
Okay.
these contracts are from a smart contract perspective,
Hmm.
right? So all the trade which is happening, right? So they did a trade volume of something close to $730 billion worth of
Okay.
trade, right? That's a trade. That's the first pilot program they did, right,
Hmm.
across these 4 countries. So all the trade happening between the countries of around you can say around the $750 billion trade,
Okay.
right, happening through the blockchain, where the
Hmm.
smart contract plays a big role in terms of validating the transaction between party A to party B, or maybe there are multiple parties coming in the pipeline of transaction, right? And then all those validations of whether how the transaction move forward, right? All are done through a smart contract. So now the
Okay.
advantage over here is compared to a like one country can't take a unilateral decision over here
Okay.
because it's a consortium, right? So you
Hmm.
can't
Hmm.
you can't have a monopoly kind of a stuff
So
because
as it is distributed ledger, the contracts written by the other party are more clearer in terms of what they want to look at in the contract. That's what you're saying?
that's good. That's good because everybody are part of that contract,
Yeah.
right? So
Okay.
if somebody doesn't like, let's say somewhere down the line, somebody doesn't like the contract, right? Then that party has to come. Then everybody has to agree. Then
Hmm.
they might come. They might maybe change the contract or maybe add a new contract, right?
Okay.
But whatever it is, right? There has to be a consensus mechanism across
Hmm.
multiple parties, and then all those things are visible to all the parties
Okay. Okay.
involved in that, basically. So in that way, nobody can go and unilaterally change a contract or anything,
Okay. Okay.
right? Because because that's what, because the thing is, even the like the way a transaction is getting committed, the contract is also getting committed to the same distributed ledger,
Okay. Okay.
exactly the way that's an admin process, but exactly the same process involved for a transaction commitment,
Hmm.
right? So
Okay.
when you change the smart contract, let's say smart contract version 1, now let's say some scenarios change, some no, let's say some global trade practice has been changed, so you have to enhance something, you have to add something to the contract to ensure to take care of new things. Now once that is agreed, the contract is committed to the ledger,
Hmm.
right, network, and which is approved by everybody in the ledger, basically, in the network.
You had a presentation. Would you like to run through that presentation, Raf?
Yeah, I have a presentation also.
Yeah, I let me bring that presentation on to the this one. They're
Yeah.
able to navigate it. Yeah,
Okay.
yeah.
You can see my presentation, right?
Yes, yes, I can. Yeah.
Okay, so I'll just quickly go through
Yeah,
the concepts and smart
sure.
contracts, right? And then I'll talk about assets and tokens because that
Yeah.
plays a big role in today's world. And then I'll talk about CBDC, that central
Hmm.
bank, and how central banks across the world are moving towards the blockchain kind of a technology. And again, when the central bank is involved, and it's primarily for your global trade, and then how
Hmm.
the transactions are happening, right? So,
Yeah.
like I said, no, because SWIFT is getting, I mean, especially after the Ukraine war, right? Now, a lot of countries are moving away from SWIFT, right? And then they don't want to have a one country taking dominating the entire stuff, because the moment you have a distributed ledger, right, everybody has got almost equal say. Okay, so so let's understand the challenges with the centralized system. Your centralized power, that's exactly the case with SWIFT. What happened to SWIFT? Because the Western countries can decide whatever they want to decide, and then everybody else has to follow it, right? So that's one of the key issues: the centralized power, and then lack of trust, integrity, lack of traceability, right? Again, I mean, this is when you talk about traditional systems, lack of visibility, right? High operating cost, and a lot of middlemen in the picture, right? So that's the way any centralized system, and these are the the critical challenges faced by either enterprise or governments or the customers across the world. Okay, so there are two concepts, right? I mean, distributed database versus distributed ledger, right? So when you look at the distributed database, right, you have a database which is distributed, right? Everything is trusted, and the user is coming from outside. Okay, or right now the thing is everybody need to trust this particular database which is centralized from that person, even though database is distributed, right? But then still everything together, it's a centralized system. Compare that to distributed ledger, right? Like for example, if there are 10 countries participating in a distributed ledger for a cross border transaction, or let's say let's take the case of Walmart, where they want to have or let's say the case of Apple iPhone, where the 1,500 components are manufactured by, let's say, 700 suppliers across the world, right? So there's a manufacturing suppliers, components coming in, then components are assembled in one location, right? Then and then put together, and finally the products are shaped across to different, right? So all those things, every country, every enterprise will have their own systems, and that's what the distributed ledger is talking about, right? So you have a organization A, B, C, D. They all have their own stuff, their own trust boundaries, but then they're ensuring that everybody will have exactly the same replica of the data with the contracts, right? So so if you look at the node C, right? Let's say node C is let's say Apple in US or Walmart in US. Whatever the transaction they have in node C, the same set of transaction will be there. I mean, depends upon the contract. The same set of transaction will be there in node B, node D, which is different organization, different manufacturers, right? So the transaction will be exactly the same, right? And it's immutable in nature, so that that's where the trust is coming in. Okay.
Yes, sir.
Okay. Yeah. So, so that's a difference between a distributed database and distributed ledger, where every organization will have its own databases, its own systems, but then they're all, from a transaction perspective, they're all in sync. Okay, so let me do a typical scenario with enterprises, right, where a lot of different parties are involved, right? So the problem statement is like so you have a bank will have records, right? Merchants, customer will buy something from the merchant, right? Customer will make a payment. The payment will come through customer's bank to the merchant's bank. Then you have a regulators, you have insurers, you have a auditors, right? So everybody will have their own silo,
Hmm.
right? And if there is a problem, then everybody has to reconcile their own records with other records, and then see where exactly the problem is, basically.
Okay.
Okay. Now, how do you, and then that entire reconciliation model is pretty expensive, and it's vulnerable, and it's absolutely it's inefficient, because there's a lot of manpower required to do this reconciliation. When there's a problems, there's no problem, then everything goes smooth. But the moment there's a problem, right, there is a dispute, right, then the reconciliation is pretty
Difficult.
yeah, difficult, and it's pretty expensive.
Hmm.
Okay. Now, the way the distributed ledger solve the problem, you have a shared replicated permission ledger, right? Like that's what the ledger the database we saw in the distributed ledger. Every enterprise will have the data, right, in their trusted network, but then the data is exactly same across all the different parties involved in that, right? So, which means, all right, once the transaction is committed, every party knows exactly what kind of transaction is getting committed, right? So there's no change, right, because the data is shared between all the different parties involved over there, right? So here, you are ensuring that, based on the smart contract, the transaction is getting committed. So there's a consensus, there's a immutability, because nobody can go and tamper. Because even if, let's say, somebody tamper the merchant data, the
Hmm.
bank data will not will show completely different thing.
Okay.
And the way the distributed ledger implementation works is basically, when bank record, auditors record, regulators record, insurer records, all same, and only the merchant data is different. So what all these four systems will do is basically they'll identify that particular record as rogue from a merchant perspective, and then all the four will take consensus to override that with a majority information,
Hmm.
right? So that is the reason why it's difficult to tamper with the data, like, because if you have to tamper this, then you have to tamper every parties at the same time,
Hmm.
right? And that's why it's difficult to tamper with the data, basically. And because it's immutable in nature, you can the provenance, basically, it's, you can track the entire history of what happened to the transaction. Like, for example, supply chain is a very good example of that. Like, for example, Apple want to ensure that the quality of each component is maintained, so that, at the end of the day, the iPhone users, right, you just look at the phone, and then if something goes wrong, right, you're just going to blame the Apple for that,
Okay.
right? But then the issue could be, one small component, which is there is a because of some manufacturing issues, or that component is bad, and that's causing the problem, and that component could be coming from a specific entity somewhere in the world, basically,
Okay.
right? Now, when you have a supply chain in a distributed ledger, right, it's much easier to pinpoint exactly from where the material came, right, how it got assembled, right? You can trace back the entire stuff,
Hmm.
right? So that's how the distributed ledger, right? So supply chain is just one example, but then I mean, you can apply the same thing in a healthcare stuff. Like, for example, a patient is going to the doctor, right? Especially if you look at the United States, right? There's a lot of regulations and everything in terms of privacy and everything, right? So HIPAA privacy is there, right? So so the insurance, the records are completely secured, right, and immutable, and in nature, right? So you go to the a hospital, right? Now you go to a lab to take your some test to be done, right? Then you buy medicines from the pharma, right? So a lot of places, some part of your record are shared, right? So that's another a classic example of how distributed ledger can ensure that all the parties will get the data, and then its data is secure, and then it's safe from that perspective. So the properties are distributed ledger, so no central authority, right, controlling the system, like a government or a bank, or a big large corporate. Everybody has got equal say based on what the contract is all about, right? And because there's no central authority to manage stuff, the trust and transparency, it's absolutely clear to all the parties involved in. And there's a consensus protocol, like how the transaction need to be committed, or how, when a new contract is created, or a contract is upgraded, right? who need to approve for the contract to go back into the ledger, right, to the platform, right. So all those things are visible to all the parties involved, and then it's a permanent, immutable data set. And smart contract plays the big role in terms of executing, how the transaction should move from one place to another. Okay, so from a business perspective, right, the requirements of privacy, right, you need to have a, complete privacy on what's happening, right, and then a trust, right, and then the it's up and only shared ledger, and the business contracts are written uh, uh, and then that's again approved by all the concerned parties. So these are the business requirements, right? So when you look at the blockchain properties and business requirement, right, these are working perfectly well, and in a lot of environment where cross organizational transactions are required, or cross country, cross border transactions are required.
Okay.
So these are properties we just discussed. These, it's a completely decentralized, right? Its information is immutable, right? You can trace back the history of the transactions, right, or the history of the assets, how the assets are moved across different countries or different entities, and and then like the way systems of record, right? This is showing systems of proof, right? So you are ensuring that like what are the data what you're seeing, it's 100% verified and authentic data basically, and every party will see exactly the same data, so there is no issue, dispute, or anything. Okay. Yeah. So how the blockchain works is like some party will start the request for a transaction to be committed, right? And then the transaction will be sent to the cluster, and then the transaction will be validated by any of the node in the cluster, and it based on the consensus algorithm in that particular environment, right? If it requires to be assigned by three different parties, then it will ensure that all those signing is been done, and then once it has been done, then the transaction will get committed. And if there is any, I mean, when I say sign over here, I'm not saying a physical sign by an end user. It's all part of the smart contract. So the respective system will automatically validate the properties of the transaction, and if it is matches with the contract, then the transaction is being signed. Or in case if it doesn't match with the contract, then it's not signed, it's rejected. But then the key aspect over here is whether the transaction is rejected or approved, the transaction will get committed to the ledger with the current status of what exactly happened with the transaction. So in that way, if something is let's say for example, there is a delivery time given by let's say a company A with a grace period of 5 days, and if it is delivered beyond that 5 days, then there should be some kind of penalty applied in terms of, let's say, some kind of the financial amount has been reduced, or let's say something like that, some validation like that. Then that will be done automatically. Or if it is delayed after the grace period, then the transaction is rejected. So all those things will be applied automatically by the smart contracts, and then whether the approved transaction or rejected transaction will get committed to the distributed ledger basically. Okay, and once it's committed to the ledger, that's when the client who started the transaction will get notified. Okay, the entire transaction is committed. Now this is the current state of the transaction basically.
Okay.
So there are private and public blockchains. So public blockchains are, it's a completely different, concept altogether. I mean, technology wise it's same, but then the implementation wise, the way it's been used will be completely different compared to a private blockchain, which is primarily used by enterprise. from enterprise, I mean, used by enterprise across the country or the within the country, or banks across different countries, right? We talked about the Mbridge blockchain technology, the the banks across, four different countries, they're coming together, to create cross border transactions, right? So that's a typical private blockchain where not everybody can access it. A public blockchain means everybody can access it, you can do a transaction and everything, right? And it's a public blockchain network. Examples of that is Ethereum, Bitcoin, right? These are all public in nature, basically. Yeah. So Bitcoin is a it's a implementation for blockchain technology. So that's a currency, right? So you can create similar currencies. There's a lot of cryptocurrencies are available right now, and then the identity. I mean. The user's identities can be anonymous in that particular case, but compared to that a private enterprise based, where the identity of the user is critical, when the transaction is created, basically. And selective endorsement means, you decide, who are the people involved in terms of committing that transaction. Yeah, so we looked at these public blockchains, private blockchains, right? Permissions and consortiums. These are different types of blockchains. I mean, the technology is same, but the way it's been implemented, the way it's been utilized by different parties, different organizations, there'll be slight variations in the way it's been used. Yeah, so we talked a lot about smart contracts. So the key properties of smart contract is self-executing, right? It's immutable nature, like the way the transactions are immutable, the contracts also immutable nature. If you have to make a change in the contract, then a new contract is created with a new change, and then that needs to be approved by all the concerned parties, and then committed to the ledger. And once it is committed, then again, like anything in ledger, it's immutable, and then that new version of the contract will get executed, for the new set of transaction, right? Again, it's completely decentralized, not a single person is managing the smart contract. It's transparent, means all the parties involved in the smart contract can read the code and understand what exactly the code is doing, and then they can verify the code before they approve before they commit the contract, or approve the contract for the ledger, basically. No. Trustless in the sense, you're not trusting a central authority for doing the right things, because you're part of that authority, and then you're focusing on, ensuring that, the contract you're signing, right, it's exactly what, the contract, you are agreed between the parties. Yeah. So we just discussed this, how the conditions are created, how it's getting executed in the ledger, and then the contract is also part of, like, another transaction, which is stored in another space in the ledger, basically. So a decentralized finance, that's one example. Supply chain, we talked about Walmart as an example for real world case. Then insurance, real estate, right, the intellectual property. So all those different examples, we can use some blockchain with smart contract, or distributed ledger with smart contract technology. Yeah, some of the misconceptions we already discussed in the beginning. The others are like other misconceptions are, like, smart contract will eliminate, not necessarily it will eliminate all the third parties, or it won't replace traditional contracts, because the smart contracts are primarily focused on what need to be verified, what need to be checked from a transaction perspective. So those are the things which can go into the from a contract perspective. But otherwise, if you look at a typical contract, right, there are a lot of other things, which may not be implementable, and not necessarily, you need to implement from a transaction perspective, right? Right. So those things will be still in the in your traditional contract, but then what from a transaction control perspective, transaction verifiable perspective, right? Those are the things which will go into the smart contract. right? So not necessarily it will be fully autonomous, right? So smart contract, what are the tasks you need to do within that particular context, that could be automated, but then how the task getting triggered, that could be by maybe a manual operation from a user from another system, right, or another system generating that, right, based on some user, right. So all those things will be can't be automated as part of the ledger, because what is getting automated is within the context of the ledger, within the context of that particular contract. That those are the things which is getting automated. And if the contract says if this transaction happens, then in this particular organization need to have this particular information need to be triggered, which need to trigger something down the pipeline. It can only trigger that event, right? But then if somebody else take an action based on the event, that smart contract may not be able to check or verify, right? But then it can ensure the what are the event you need to send out to somebody else. That part it can ensure that. That's why it's say it's all when say fully autonomous. That doesn't mean that everything is fully automated.
Okay.
Yeah. So we looked at the right the problem
We
statement.
spoke about multi-party environment.
Yeah,
Yes.
that's right. So if there's no multi-party environment, right, then there's no reason to go with the blockchain, because
Hmm.
it's been overkill.
Okay.
It won't serve the purpose. You're unnecessarily complicating the stuff, right? So if
Hmm.
you want to build an application with there's no multiple, that says the moment you talk about contract, right, there had to be two parties, right?
Yeah.
Right. There's only one party, right? There's no concept of a contract,
Hmm.
right? So that's it. So the moment it's a contract, right? It's a multi-party environment, right? So the parties can be across the country, parties can be within the country. So it doesn't matter geographically where the parties are, right? As long as the two
Hmm.
parties are involved, then distributed ledger is a perfect solution for that. Yeah. So it saves time. Right, it reduces the risk, right. The trust is increased because the contract is transparent, the transactions are transparent between the parties, right. So there's no issue of reconciliations or anything, right. And a lot of overheads have been removed because of you're doing a lot of reconciliation from a side of perspective. All those things are removed, and that's why you are reducing the cost from that perspective. So that's the benefit from a distributed chain technologies, distributed ledger technologies. Yeah, so I'll just skip this use cases. So we
Okay.
discussed a lot of use cases before.
Hmm.
Let me just show you something more interesting, because assets and tokens, right?
Okay.
Yeah, so assets are, assets and token, it's a very interesting area in blockchain technology where um, so there are a lot of different types of assets over here, right? Um, you have a tangible assets which has got any asset with a physical form which has got a monetary value, that's a tangible. Uh,
Hmm.
Fungible assets that can be interchangeable, right? Like for example, gold, silver, right? Those are uh, interchangeable assets. Assets that can't be interchanged with something else, basically, right? So that can't be interchanged is basically your real estate or a painting or a diamond, right? So because you can't replace diamond with another, right? Because it's all the cut will be different, everything. Right? So
Hmm.
that's the concept of a non-fungible assets. Okay. Now there is a concept of a tradable assets, and asset the way assets can be tokenized, and the and it's tokenized, and then it can be represented as a token within the blockchain platform. So let me give some examples over here.
Okay.
So if you look at a token from a real world case, right? So what is a crypto token is all about? Right? So if you go
Hmm.
to the movie ticket, right? The ticket is valid for a specific show, specific theater, right? In a specific city, in a specific time, right? So
Right.
you have a token, and the token is valid for the time, and then you can use the token to do certain one. Similarly, your boarding pass, or you go to uh, a gambling center, and then you get a token over there, right? So these are different type of token in a physical world. So similarly, you can create crypto tokens. Like for example, there is a there's a large business building, right? So now people need to buy, let's say, office space, in square feet or something like that, right? So which can be potentially very expensive, and it's not easy for let's say a common man to buy, right? So if you create a huge amount of tokens out of the asset value, and the token value is something very small, then somebody can invest in that building, right, with buying a few set of tokens, right, which actually represent a physical asset value from that. In that way, it is much easier to um, sell that a part of the building, right? So getting investors to buy the property, right? So all those things will help you to streamline that heavy costlier assets by breaking down that into a smaller tokens, and then it's much easy to do the trading from that perspective. And even let's say if I have a very um, uh, a popular business center, I own, let's say, 10,000 tokens, let's say, which values, let's say $100,000, because each a token is let's say $10. And if I want to let's say sell that 2,000 tokens out of that, the building value may be costing, let's say, $200 million, right? But then I own $100,000 worth of token from that asset perspective, that physical asset perspective. Now I can sell that to you. You already have $200,000 or 20,000 tokens, right? You buy 5,000 tokens from me, so you increase your rate. And then another aspect of it here is the liquidity of that token, right? But if I have to sell that a property, and if I'm holding a property which is, I mean, let's say the value of the property is let's say $200,000, 200,000, let's say, rupees, which is let's say, or let's say, let's talk about in million or in crore, right? It won't be easy to find a buyer. Now, because the tokens are small, right, it's much easier to liquidate your money, in case of emergency, or finding new buyers from that perspective. So apart from we talked about a lot of different use cases, right? You talked about supply chain, you talked about the financial transaction, cross-border financial transaction, right? But here, another set of use case were coming, where any asset, right, you can tokenize, and then you can do trading of that asset based on the token on a distributed ledger. So these are different types of tokens. So you have a currency, which I think everybody, everybody's aware of that. Then asset-backed token like real estates, or reward tokens, or governance tokens, right? So, like for example,
One doubt here. So, when you say real estate as a token, how
Mhm.
does that come up as a token? Any specific example that we can look at?
Yeah. So let's say you have a business building
Hmm.
where the cost of the building is, let's say, is $10 million.
Okay.
Now, only somebody who's pretty rich can buy that building,
Hmm.
and they're 10 billion, right? So instead of $10 billion, right? Let's say if I created 10 token, right? That's 1 billion each,
One
or
million.
I can make 100 tokens or 1,000 tokens, right? Then the value of that token will come down,
Hmm.
right? Now, let's say the business is creating a profit,
Hmm.
right? And then the building is generating a profit, and then whoever owns that will take a share of that profit, basically,
Hmm.
right? But
Got it.
then because the cost of the building is so high, right? Normally, normal, I mean, common man won't be able to invest in that.
Hmm.
Right? It's like, you buy a share of a company, right?
Okay.
Right? Like for example, if you look at the Apple share, and maybe, I don't know, maybe $150 or something like that, right? But before, I think 4 or 5 years ago, right, it was $100. When it goes reach certain level, right, they split the shares,
Split the share.
right, into smaller, so that it's much more easy to people to buy,
Hmm.
right? So it's exactly the same concept. So the way the shares getting split when the share prices goes up, so that it's again much more easier to do trading. Exactly the same concept, right?
Hmm.
You have physical assets, you make it tokenized, and token value is small, so that a lot of people can put in their investment in and invest in that particular asset basically. And whatever the revenue the asset is generating, you get a share dividend of that, right? Exactly the way it works in the typical share market. Right, so there are a lot of use cases like these right now. I mean, tokens, assets and tokens, right, plays a big role in the blockchain, the distributed ledger uh, domain.
Yeah.
Yeah, so we looked at a lot of different tokens. So yeah, so we looked at the non-fungible asset. Now non-fungible tokens are also there, which is primarily to do the digital art, digital music, and everything. So that's also another area where a lot of artists and everything, right? They are creating NFTs.
Hmm. Hmm.
So the advantages of this is, it's a greater, like if you have an asset, right? Let's say you have an asset which is worth let's say 5 crore, right? And it won't be easy to sell it, right? Because you need a buyer, we can afford to buy, right? But then if it is based on token, right, then it's much easier to sell that basically. Let's say maybe 10 parties might come in, right, and then put their amount, and then they will maybe, let's say, they put 50 lakh each, and then they'll buy the property,
Hmm.
right? So that's so the entry barrier is removed, right? And because it's all in a distributed ledger, it's the transactions are safe, right? It's immutable, right? You know exactly how things happening, right? And and liquidity, it's much easier to do your buying and selling of any assets or any items from that perspective, right? So almost every industry right now, the tokenization is possible, right? So that's another big area where there's a lot of momentum happening in those areas. Okay, so let's look at the central bank digital currency, right? That's where, especially like I said, after the Ukraine war, right? The moment on this, it's pretty huge, and
Yeah.
so there is a huge amount of momentum happening in this area basically. Right. So there's a wholesale CBDC that's primarily between transfers between banks in DHM, banks across the countries, especially the cross-border financial transaction, global trade, and everything. And retail CBDC is it's primarily meant for direct transfer, those kinds of features where it's much easier for the government to do all those kinds of transfers. Okay. So let me just go one specific example uh,
Okay.
from India perspective also.
Yeah.
Yeah, so there are already India is also already into that CBDC mode with the digital rupee and everything. So digital rupee is already announced, right? And then you have already nine banks linked in the CBDC from in India perspective. And the PPI is another prepaid payment instrument where there's a lot of momentum is happening in that. Sometime back, a few years back, I was involved in a project where the company was focusing on building based on the RBI PPI prepaid instrument. Right, it's much easier for you to do a transaction using your mobile phone, basically. So all this concept of a wallet coming in your phone pay or Paytm or Airtel, right? Or it's all part of the RBI's prepaid payment instrument guidelines. So these are there. So I'll just skip this because again it's a public document. The
Hmm.
RBI's prepaid instrument. What exactly the prepaid instrument? Like for example, there is a new stuff thing UPI Lite. where
Hmm.
any transaction under 500, right? There's no authentication or anything, right? You can immediately make the payment basically,
Okay.
right? Yeah. So let me just talk about M Bridge. That's a multiple CBDC bridge for central banks, China, Hong Kong, and then 25 banks across the world are part of this. So Bank of Thailand, Bank of China, UAE, and Hong Kong. Now I think Saudi is also joined in this, and then more countries are joining in this, and then their trade between all these countries are happening through the Mbridge instead of SWIFT, right?
Hmm.
Their transaction is happening through the Mbridge distributed ledger technology. So these are the different banks, Standard Chartered, HSBC, Bank of China. Um, yeah, so these are the 25 banks across the world which is participated in this particular program. This program was on for last 4 years,
Hmm.
right? So these are the different the 13 use cases, right? So they completed the pilot program, and they completed, I think, few months back. They completed the minimum viable product MVP also is ready, and then with the real with the real world transition happening between these four or five countries. So these are the different transaction type, right? You have a cross border payment, right? You got a cross border foreign exchange payment, right? So all those different types of payments can be handled through the M bridge. So you're going to see soon. I think Mbridge it's going to I think it's going to open up for a lot of different countries to join
Hmm.
this particular network, right? So everybody is good. The entire thing is completed. It's not owned by any one country or any one entity, right?
Okay.
Everybody has got ownership into this because because it's part of a decentralized. It is a key feature of a distributed ledger, right? So that's a key. That's the highlight of this entire Mbridge, basically. Yeah. So the MVP is done. I think there is a news on that a few months back,
Hmm.
right? So MVP is completely done. So now they are going for the next layer of adding more countries and things. So this is another area where distributed ledger is going to play a big role. So you don't see a momentum like a traditional application development. Like I said, if there's only one party, right, there's no role for because mostly when you build an application, right, you're building an application for an enterprise.
Hmm.
But here, because there's a contract, right, because everything is built on a smart contract, right, there has to be it's a multi-party
Yeah.
environment. Yeah, so there are a lot of similar projects happening across the world. In Europe, in Latin America, in North America, Asia, right? So there are a lot of different projects. It's happening on a distributed ledger technology. Yeah, this is just a technical comparison between different platforms. Under the hood, you have Ethereum, you have Hyperledger Fabric, you have R3
Hmm.
Corda, right? So you have a lot of different technology stack under the conceptually everything is same, but underlying implementation can be varying depends upon which technology stack you're using. Yeah, that's it from a presentation side.
Yeah.
Any other questions, Prem? Or
I have two questions which I would like to get this one. How can businesses handle this complexity of ensuring compliance with nationwide regulations while using smart contract? That's one question I have.
Mhm.
The other is, what are some of the risks uh, known or underestimated while we face adopting smart contracts? These are two questions which I wanted to understand from you.
Yeah. So, yeah, I think the first question was, on the risk involved, right?
Yes.
Yeah. See, like, if you look at, in a traditional app development, right? Primarily, the risk will be related to the technology and how you are, you're building the stuff, right? But here, it's not only the technology part, right? You have to ensure that multiple parties are fully committed to the entire project, basically,
Okay.
right? So that itself, it's a business risk. Ensure
Hmm.
that everybody is adhering to that those goals, and then they're coming together, and then they're ensuring that their side of this, because you can't even though two parties agree, you can't deploy the distributed ledger only in one party.
Yeah.
Distributed ledger has to be deployed in multiple parties, which are, let's say there are three parties involved. All the three parties need to support distributed ledger in their private cloud or public cloud.
The other question was to look at, that was the second question which you answered. The first question was about to look at complexity of ensuring compliance with different nations' regulations. That's the point that I wanted to understand on
Yeah.
the first point.
Yeah, so yeah, I think that. So if you look at let's say you are, let's say you created a distributed ledger from, let's say, a banking perspective, or let's say you create a distributed ledger from a healthcare perspective. Now, if
Hmm.
you look at the compliance perspective, right? Let's say, let's take the case of um, a medical environment where now the labs, right? The lot of medical transcripts are done, is being offshore to, let's say, India,
Hmm.
right? Now, so the information is coming, right? The transcript is done by over here, right? Now in India, you may not have a law the way it's been there in US, from a privacy and security perspective, like HIPAA, from a HIPAA Act perspective,
Okay.
right? Now, but in US, you have to ensure that that is being followed,
Hmm.
right? So every country will have a right, but then you have to ensure that even if the other country doesn't have, right, but HIPAA says no, every party involved in that particular ledger need to focus on complying to that HIPAA, right? Even though the party is outside this outer, right? Now you can ensure that that is part of your contract,
Hmm.
right? Like for example, right, let's say you can say the transaction is encrypted, right, and then it can be viewed only by a authorized I'm just giving an example, right? So
Yeah.
irrespective of wherever it is, right, the transaction has to be encrypted from that perspective.
Hmm.
When
Hmm.
you say transaction encrypted from a REST perspective, not on the wire, transaction is saved in a database, right, from that perspective. So irrespective which all party involved, and if it is HIPAA is there only in US, it doesn't matter, because your contract says all the party need to ensure these guidelines from a security perspective, right? So in that way, you are ensuring that the guidelines is met by all the right. So you are to every if it is the moment it goes across countries, then you will have a regulatory issues. Like for example, if you go to Europe, right, then you have to support GDPR,
Okay.
right? So even though you are, let's say, five countries involved are not part of Europe, so they don't have to worry about GDPR. But then if one country is there in Europe, it is focusing on GDPR. It says that all the parties involved in this particular transaction should ensure the user's privacy. Then that affects other parties also,
Hmm.
right? So then you have to
Yeah.
ensure that you are taking care of that from a smart contract perspective also, so that it's much easier to handle that.
Okay. Okay, we got a fair amount because I am new to the whole structure of distributed ledger Raf. So
Okay.
I have got little more knowledge that I could observe in our session today. I think we've covered. I'll just want to summarize on what we covered today for the audience to have a view on what we discussed. We spoke about foundations of the smart contract, what
Hmm.
impact it has on global trade, challenges in implementation, what we said, and some of the use cases that we spoke about, and how the operations or the smart contracts are managed with multi-party cross-border stuff that we discussed about, what way it is being used at the current this one, and what could be the piece of pointer where national compliances were looked at for cross border or navigating the complexities, and the compliance was looked at, and some known and unknown risks were discussed. I
Hmm.
think this is what we covered in our session of smart contracts using our blockchain topic, which is blockchain demystified, how smart contracts are reshaping the global trade. That's what we have discussed. Had a great understanding on the topic, Araf. And to the audience, if we want to have a connect with Araf and know much more, he's been speaking on your LinkedIn, and he has been part of many of the talk shows that are there. He's been on our session for the second time, I think, Araf, right?
Yeah, that's
You've
right.
been there. Yeah. Thank you for being here. It's a pleasure having you as always, Araf.
Thank you,
We
Prem.
are, yeah, we are live on YouTube and Facebook in parallelly at the same time. I hope this session was valuable, and this makes us to conclude the session. Thank you for joining us. Our next podcast is on tomorrow: adaptability, responding, and evolving to change. 11 September at 6:30. Looking forward to see you again. Good day. Goodbye. Araf, any last minutes pointers that you want to look at? Then we
No,
can
no,
conclude the show.
thank you, Prem. Thank you inviting me for this podcast. Thank you. And it was a great questions.
Yeah. Thank you.
Thank you.